we are going to solve some numerical problems based on Ohm's law. Okay, so the first question is, when a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. Okay, so in this case we don't know the value of resistance, but when 12 volt is applied to a circuit, then the current is flowing through a circuit, so that is 2.5 milliampere. Then we have to calculate the resistance. Okay, so first given quantities we should write. So I is equal to 2.5 milliampere. So we have to convert milliampere into ampere. So that is 2.5 into milli means 10 power minus 3 ampere. And voltage V is equal to 12 volt. Then we have to calculate the resistance R. Okay, so according to Ohm's law, we know the formula. So V is equal to I into R. And we have to rearrange this formula. So this implies R is equal to V divided by I. So R is equal to the value of V is 12 divided by the value of current is 2.5 into 10 power minus 3 ampere. Okay, so this implies 12 divided by 2.5 and 10 power minus 3 is nothing but in numerator it is 10 power plus 3. Okay, so the 10 power plus 3 is nothing but 1000. So 12 into 1000 divided by 2.5. So the value is 4800 ohm. Okay, so this is the answer. Next, second question. Calculate the resistance if 5 ampere of electric current flows through a conductor having a potential difference between the 2 points is equal to 15 volt. Okay, so in this case we have to calculate the resistance. So that is R is equal to question mark, and first we should write the given quantities. So the current I is equal to 5 ampere, which is flowing through a circuit. Then the potential difference V is equal to 15 volt. Then we have to calculate the resistance. So the according to Ohm's law, V is equal to I into R. So this implies V is equal to the value of V is 15, it is equal to, and I is 5 ampere into R. And we have to rearrange this formula. So that is R is equal to 15 divided by 5. So this implies R is equal to 3 ohm. Okay, so the SI of resistance is ohm. So the value is R is equal to 3 ohm. So next, third question. A simple electric circuit has a 24 volt battery and a resistance of 60 ohm. What will be the current in the circuit, and the resistance of the current in battery is negligible. Okay, so in this case we have to calculate the current which is flowing through a circuit. So first we have to write the given quantities. So first one is the battery voltage, it is 24 volt, and the resistance R is equal to 60 ohm. Then we have to calculate the current which is flowing through a circuit. So that means we have to calculate I. So according to Ohm's law, V is equal to I into R. And we can rearrange this formula. So this implies I is equal to V divided by R. So I is equal to the value of V is 24 volt. 24 divided by the value of resistance R is 60 ohm. So this implies I is equal to 0.4 ampere. Okay, so the current is 0.4 ampere which is flowing through a circuit. Next, fourth question. Calculate the equivalent resistance when two resistances of 3 ohm and 6 ohm they are connected in parallel. Okay, so in this case we have two resistances, 3 ohm and 6 ohm resistances. So they are connected in parallel. resistances. Okay, so let us consider. So this is one resistance and this is another one resistance. So the first resistance consider. So R1 is equal to 3 ohm and R2 is equal to 6 ohm. So these two resistances, they are connected to same 2 points and the potential difference is applied. Okay. So consider the R1 is equal to 3 ohm and R2 is equal to 6 ohm. So these two resistances, they are connected in parallel combination. Then we have to calculate the equivalent resistances. Okay. So we know the formula of the parallel combination of resistances. So that is 1 divided by R is equal to 1 divided by R1 plus 1 divided by R2. Okay. So R1 means it is the first resistance, R2 means it is second resistance, and R means it is equivalent resistance. Okay. So R is equivalent resistance and R1 and R2, these are two resistances, they are connected in parallel combination. Okay. Then we have to calculate the equivalent resistance. Okay. So 1 by R, which is equal to 1 divided by the value of R1 is 3 ohm plus 1 divided by the value of R2 is 6. So this implies 1 divided by R is equal to, so we have to take LCM. So the LCM is 6 and then 3 2s are 6 and 6 1s are. Okay, 2 plus 1. So 1 by R, which is equal to 2 plus 1, 3 by 6. So 3 1s are, 3 2s are. So this implies 1 divided by R is equal to 1 divided